In this session, we will be discussing few programs related to C, and also we will discuss about control statements. So first let us see few programs. The first program is a sample C program to print the desired statement. Here I have written hello C. You can check that the first statement, it is the preprocessor statement. Hash include stdio.h, where we say it as a preprocessor statement. As I told you in the previous video, it is mandatory to write a preprocessor statement where it includes all standard input output header files. So here H indicates the header file, and the main function is compulsory for any C program because the functionality starts from main method. And I have written int main. This is my main function and closed by parenthesis. And I'm opening my flower brackets. Okay, inside this you can write your statements. Here I have written printf, and in double quotes I have written hello C. Remember, I am ending it with semicolon, and this is a return 0 statement. We will be learning about return statement in the further classes, but it is simply nothing but if there is no any return type to your main method, then you need to return 0, nothing but your program gets terminated, or else your program will be running on. So let us execute this. You can check that this is Dev C++ environment, which is free and easily accessible. I have used this environment. It's very simple to write codes. Just you need to click file new, and you can see that source file, and in this new source file you can write your C codes. And this is my program which I have written. Let us save it. You need to save. Okay, I hope you know how to save it. And remember, I want to tell you one more thing. Suppose let us rewrite this program in this new file. So how we will save? Control S, and wherever you want you can save, in desktop or libraries or PC, wherever. And remember, whenever you save your file, remember you need to save it as C source files or .c files. This is very important. You need to save it as a C source files. You need not save it as a resource scripts or header file C++. Okay, yours is a C program. You need to save it as a C source file, and you can click on save button. Okay, so let us run this program. Here you will be having execute option where you will have compile and run. You can use F11 key, or you can click here compile and run. Okay, so when you click compile and run, a command window will get opened. And you can see that my output is hello C. Okay, I have just given a printf statement, and that statement is been printed. Let us look at with another program. Yeah, this is the program related to data types. Okay, as I said, we have char, int, float, double, and more data types. Here again I have given the header file having main method. Initializing, I am initializing a variable called as marks to be 5, and remember this marks is my integer variable. Okay, int marks equal to 5, and ending it with semicolon. Remember, whatever statements inside this block you will write, you need to end it up with semicolon. Okay, if you end it up with semicolon, you can say that this marks variable is declared. Okay, that marks variable is declared. This is initialization, and if you keep this semicolon, the variable is declared. Okay, and here I have used a printf statement printing hello world. And remember, here very important point, here comes what is the question comes is what is percentile D. So whenever you print or you scan, remember that directly if you write here marks, this 5 will not be printed, some address will be printed. In the previous session we have discussed, right, each number or each character or each alphabet has a different ASCII value, so that ASCII value will get printed in the output. So here I am using percentile d. If I use percentile d, then that integer will get printed, nothing but whatever the integer we have assigned to that marks, that integer will get printed here. Okay, percentile d. For int, whatever you have given here int, you need to write here percentile d. Suppose if I give here float, you need to write percentile f. Okay, in that way you need to write. And suppose if I give here char, you need to write percentile percentage c. Okay, in that way you need to do it. And again I am reassigning. Initially my marks was 5, I am reassigning it to 10. Okay, and again I am printing it. Hello world, I want to print the 10 as well, and this is a return statement. Okay, I hope you understood this program, and let us run it. Compile and run. You can check both the statements are printed. First int marks equal to 5 and hello world 5 is being printed, and after that marks equal to 10, I am reassigning hello world marks and 10. Okay, right. So let us look at with another kind of program. Right, this is the program to show the use of scanf statement. In the name itself, scanf is nothing but it is like an input function. Okay, suppose here in the before program we have explicitly specified the input as 5. Suppose if you want to take the input, okay, like instead of giving directly 5, I want to ask I want the user or the programmer to give the input. Okay, so I'm using a printf statement, like I'm saying enter 2 numbers. Before that I have given declarations. You can see int a comma b, these are integers, and float c is a float value. Okay, this program is related to average of 2 numbers. So 2 numbers are integers and the average is float. Float is nothing but having points. Okay, suppose 1.6, 2.3, these are float numbers. And to show the use of scanf, I'm telling enter 2 numbers. Okay, printf statement. Okay, and remember this /n. Okay, this is nothing but new line. Okay, to get the statement in a new line you will be using this. Okay, don't confuse with this symbol, and this implies division. Okay, division, whereas this backslash implies nothing but /n implies new line. Okay, and remember I've said I forgot to say you one thing. In C, if you want to write any statement in comments, then you can use // okay, single line comments, any comments, right? Okay, suppose if you have like multiple lines, suppose if I have AS, BD, CG like this. Okay, I cannot give only // only the first one will get into commented section, so I can give backhash slash star and again star backslash. Okay, you can, like, it's a format of writing or commenting a sentence. Okay, commenting a sentence. If you have only single line, you can use this one. And in this function, as I said, I'm declaring a, b, and this is c. This is the printf statement, scanf. So you are entering 2 numbers, right? In the printf statement you will enter 2 numbers. Those 2 numbers will be scanned. Okay, percentile d, both are integers, right? Those both get scanned and get stored in the a and b. So I am not writing a and b, I am writing address of a. I told that this represent address of a and address of b. So we are storing the numbers in these 2 slots, whatever we have declared here, and I want to compute an average. I'm using c equal to a plus b inside a parenthesis divided by 2.0. Why I have written here 2.0? Because C holds for float values. Okay. And finally, I am printing the average. Average is percentile of C. You are printing C, right? So C is a float value. You need to write percentile percentage F. Okay. Simple. And this is a written statement. Let us execute this program. Sorry, I have kept here. Yeah. You can check it is asking enter two numbers. I'm giving 1, 2, 1 and 2. So the average is 1.500. So okay. Depends, float number, right? You can give different inputs. You can check it. Post 3 and 2. 2.5. Okay. In that way. This is about the use of scanf statement. And let us look into another program. This is a simple program to swap two numbers. Swap two numbers in the sense, suppose if I give input 1 and 2, in output I must get 2 and 1. Okay. So let us check how to do it. First statement, the header file calling the preprocessor directive, and this is the main function enclosed. And initially I have defined 3 integer variables a, b, c. This is an input function. Remember, this is an input function. I am printing f. Printing f is nothing but like writing a statement, and scanning f is nothing but scanning the input given to that statement. Okay. And as you know that percentile d, and ampersand a, ampersand b. And this is the printf statement before swap. So I am writing before swapping a, b values. So before swapping, whatever the input you will be giving, that input will be getting printed in this printf statement. Now, this is the main logic for swapping. What I have done is I have used an external variable c. I am assigning this a to c, assigning a to c. So let us take an example, right? Suppose in this scanf, in this printf and scanf, if I give a 10 and b 20, okay, c is equal to a is nothing but 10. That's it, right? A is nothing but 10. You can check here, a is 10, and a equal to b. A equal to b is nothing but, now a is 20, b is 20, right? B was initially 20, and I am assigning that b to a. Now a has become 20. B equal to c, nothing but c is nothing but initially we have given c equal to 10. Now b will become 10. So from these two statements you can check that a and b are reversed. Initially a is 10, b is 20. Now a and b has become 20 comma 10, and after swap I am printing a equal to percentile d a b. Okay, and this is a written statement. Okay, after swap we need to get what? We need to get 20 and 10. Let us check. I have saved it and compile it. Let us give input, enter two numbers 10 and 20. Yeah, you can check here. Before swap it is a equal to 10 and b equal to 20. After swap 20 and 10. Okay, a is 20, b and b is 10. So how we have done this swapping? Using an external variable c. Okay, this is for your swapping. And one more point I need to tell here is, in this swap function or in this printf function, how many percentile d's you will be writing? Those many variables you need to give after end of this string. Okay, like if you have written 2 percentile d's, right? The compiler must understand, right, what is this percentile d indicates. This percentile d, first it came first, so in this a has came first, so this percentile d implies the value of a, and this percentile d implies the value of this b. Okay, in that way. Suppose if you give another percentile d, then remember that you need to write another variable. Okay, that is about your swapping. Let us look into the size of your data types, and we have to tell that in the previous video size for different data types, for int, for float, for int4, for character 1 byte, okay, for float double. So let us check using size of function. So using size of function you can predict the size of the data type. Simple main function, inside the main function I'm using a printf statement giving a percent id because size will be in integer format, giving a percent id, and for that percent id what is the variable is a built-in function. Variable is a built-in function. I have not defined any variable. I'm using percent id and I am saying a built-in function using a built-in function size of char, okay. And similarly for int size of int, and for float size of inside the parenthesis float, and for size of double inside the parenthesis size of double, okay. Let us check this whether we are getting the sizes which we have learned right. Size of character is 1, size of integer 4, float is 4, and double, as I said, double will be multiplier of 2 or multiplier of integer, and you have got 8. This is the program related to the data type size. And let us check into the operators, okay. We'll be learning how these operators will work. First, let us check into the logical operators. In the first statement, we have written a header file. Inside the main function, I have given a variable. I have initialized and declared a variable marks giving 75, okay, giving the value to it as 75. And these are the printf statements. The first printf statement, I have written a string. The value is %ld. Here I have written %ld in the sense %d in the sense you need to write some statement here, something you need to write here. I have given a condition 75 less than 80. I have given a condition 75 less than 80, and here the logical not value, here I am given exclamatory mark of 75 less than 80, and here logical and 2 logical AND operators and 1 logical OR operator checking for them, okay. So the output you will be getting is %ld, nothing but you will get an integer. So what is that integer you will get? You may get 1 or you may get 0. So 1 is nothing but true, 0 is nothing but false, or sometimes you may be getting reverse, but the preserved one is 1 indicates true and 0 indicates false. So let us check this in what format we are getting. Yeah, you can check ones and zeros are being printed in the output right here. 75 less than 80, this condition is true, so you will get answer as 1, okay. That %ld is 1, okay. And 75 less than 80 is true, but here I am using not operator, logical not, so it converts into false, nothing but 0, okay. And here I am using one logical AND operator between 2 operands. Here operands are also conditions. 72 greater than 60, this is true in the sense this is 1, and 72 less than 80, is this true? Yes, this is also true, so both are ones. So in logical AND we have discussed that if both the values are non-zero, then you will get true, nothing but then you will get 1. And similarly 45 greater than 60, no, this is false, nothing but this is 0. So we have discussed that both of them must be, both the operands must be non-zero, but here one operand you got non-zero, so this you'll be getting this as 0. And similarly here 45 greater than 60, it is false, so this is 0. 45 less than 80 is true, this is 1. But remember here there is logical OR operator. Logical OR operator, what is the definition of it? If any one of them is non-zero, then it is true. So 45 less than 80 is 1, it is non-zero. So if any one of them is non-zero, yes, this is non-zero, so you will get answer as 1, okay. You can check the outputs here. For the first one 1, for the second one 0, third one 1, fourth one 0, and logical OR is 1. Okay, this is about logical operators. Now let us look into relational operators. As I said, true is indicating 1 and false will indicate 0. Same again, creating a header file, void main. This is a void main function. So remember, if you mention here void, then no need of return type. By default, the program pointer or the program where program execution starts will get terminated. Okay, whereas if here you have used int, I am giving a return type as return 0. Okay, and here I have declared two variables a and b, and I have initialized them to 2 and 3. Okay, a and b initialized to 2 and 3, and I'm printing a equal to b. So I'm checking here a double equal to b. Okay, so what does this operator indicate? If both the values are same, then it returns true. Returns true in the sense it returns 1. But here a is 2, b is 3. So are they both are similar? No. So you will get false, nothing but 0. And here a not equal to b. Is it true? A is 2, b is 3. Yes, it is true. So you will get 1. Here a less than b. And remember, for each of them we are using %d because we are getting the zeros and ones as output, right? Those all are integers. These both are integers, right? A less than b. 2 is less than 3. Is it true? Yes. So you'll get 1. A less than or equal to b. Let us check them as well. A greater than b. Is it true? No. It is false. A less than or equal to b. So is this true or false? 2 less than or equal to 2. 3. 2 is less than 3 is true, but 2 is equal to 3 is true? No. So both, one is satisfying, one is not satisfying. So output you will get as what? 0. Okay, and here a is greater than or equal to b. Here also I think you will be getting 0. So let us check. No, you didn't get it right. Wait once again. A equal to b is 0 and a not equal to b is 1, and a less than b is also 1. A less than or equal to b, you have got it as 1, right? So if any one of them is true, then you will get the output as true. A less than b, 2 less than 3 is true, so you will get it as a true. But if you check here, a greater than or equal to b, 2 is greater than 3, no, it is wrong. 2 is equal to 3, that is also wrong, so you will get as 0. It is like a OR operator. Okay, if one satisfies, then you will get true. Okay, and let us check into the next one. This is binary arithmetic to show the usage of arithmetic operators. Here I have used the main function, the header files and the main function, 3 variables, whereas a and b are initialized to 10 and 2 and c kept uninitialized, just declared, and I am printing the a and b values. Addition, a plus b, just you say a plus b. Subtraction, a minus b. Multiplication, a star b. Division, a divided by b. Okay, this divided. And if I want modulo, a modulo b, a modulo b. I'm using an external variable c, and I'm saying that c to be a modulo b, and I'm printing that value. Okay, so here you can give your input, but I have given the inputs are 10 and 2, and I hope you know this: 12, 8, 20, 5, and a mod b. So what is 10 mod 2? Here it comes as 10 modulo 2. 10 modulo 2 is nothing but 10 is divisible by 2. So if it is divisible, then you will get a remainder as 0. Then you will get remainder as 0. The c value is what? 0. Okay, let us check it. Yeah, you can check. Addition 12, subtraction 8, multiplication 20, division is 5, and modulus is 0. Modulus will determine the remainder. This is about binary arithmetic. Next, assignment operators. Inside the main function, I have given a variable called as a, assigned it to 10. I'm using a plus equal to 30, nothing but a is equal to a plus 30. A was initially 10, so a will become a equal to 10 plus 30. A will become as what? 10 plus 30. So the output will be 40. And here a star 2, nothing but 10 star 2. So you will get 20. Right, here the important point you need to keep. A star 2. So what is the a value? A value has changed to 40. So now here you will get 10 or 40. Yes, you will get 40 star 2, nothing but the answer will be 80. I hope you understand. Just check the output. Yeah, a is 80. So what is the use of this assignment operator is, you are reassigning the a value. Okay, a value is being reassigned. It is not that you are only adding, or it is not that you are only multiplying. You are reassigning the a value. A value now has become what? A is equal to 40. Okay, this is the statement comes after that. And a equal to a star 2, where a is now 40 star 2. Okay, that is simple, and printing it. This is about the assignment operators. And next topic we will discuss about control statements. Control statements. So what is the use of control statements? Basically we have three types of control statements: selection, iteration, and sequence. Sequence is nothing but one by one, first and then second and then third. Okay, it is a line by line process. Whereas in selection you will be having you will specify a condition, and for that condition, if that condition is true, this block will get executed, and if that condition is false, this block will get executed, and finally the output will be printed. Remember, both will not get executed at a time. Any one of them will get executed. Okay, and what is iteration? Iteration is nothing but, for a condition, if that condition is true, this statement will get executed. Again, the control will move to the next iteration, nothing but next incremental condition. We will be learning in the further part. Nothing but it is like a repeating process. Not repeating the same thing, but incrementing the part and repeating. Okay. So control statements is nothing but control, the placeover of control. Okay. Here the control is being placed based on the condition true or false. Here the control is placed based on the condition we specify, and here it is a sequential control. Okay. Now the division of the control statements. There are three types of control statements: sequential, branching, and loop statements. Sequential are nothing but just you will be writing in a sequential manner. There is nothing like you specify any condition there. Just like the programs we discussed just now. Printf, writing a printf statement, and then some declaration, and then some like average to find average, some logic, you are writing some logic. That is a sequential statement. What are these branching statements? Okay, branching are of two types: conditional statements and unconditional statements. Conditional statements are nothing but specifying a condition. We can specify condition using this 5 parts: using if, you can use an if else, using nested if, using else if ladder, using switch statement. What are unconditional branch statements? These are of 4 types where you will be not specifying any condition. Go to, break, continue and return. And loop statements. Okay, so the before one, this iteration, okay, this is a loop where you are running the loop again and again. Loop statements are of 3 types: for loop, while loop and do while loop. So let us learn about them briefly one by one. First, the conditional statements: if and if else and switch. In if else you have different categories. Simple if statement. What is simple if statement? Writing if and inside the parenthesis giving a condition and opening the blocks, nothing but opening the flower brackets and writing some statement. Okay, if that condition is true, then the statement which you have written inside that block will be printed or will be executed. Okay, that is the meaning of if statement. Simple, you are giving a condition, and if that condition is true, then the block of statement which you have written inside this flower braces will be executed. And next, if else statements. Here you are specifying an else part. In this statement, you can check if the condition is true, then this block will get executed. What if the condition is false? Obviously the control will go to the next statement, whatever you have written. So in order to specify a statement or a block of statement to the false part, to the false condition, you can use else block. Nothing but write if condition, and if that condition is true, this block will get executed. And else, remember, for else case you need not specify any condition. Else case is nothing but it is a by default false case. Okay, and the statements whatever you write inside this block will be printed. This is the use of else block. Okay, if else statement. Now next, if else if ladder. What is if else if ladder? Simple, I am writing if condition 1 true. Suppose if I want to write multiple conditions, I have given here condition 1, right? I have one more condition 2, and I want to know what will be printed if that condition 2 is satisfied. I am using else if block. Else if. So else if condition 2, and if that condition is true, then the block inside this else if will get executed. And here also I'm using an else statement. If both the conditions are not satisfied, if statement condition and else if statement condition, if both are not true, then the else block will execute. What is nested if? In the name itself, nested if. Nested in the sense inside something. Okay, inside if you are writing again one more if. That is called as a nested if. So what is this nested if is? Inside we have specified here condition 1 for if statement, and inside this we have written one if else statement. Okay, if inside a if, or you can say block inside a block. Okay, here if condition 1, if the condition is true, then the inside block, the nested block will execute, and inside that nested block again I am specifying an if condition, then that program whatever you have written is called as a nested if else program. Okay, here also I am giving a condition, if it is true, this block must execute, and else case also I have given a block. And again for else, this else is meant for this outer if condition. So I hope you will understand that. We have written a simply we have written one if and one else. Inside this if there is one more if else, and inside this else there is one more if else. Okay, simple. We have written only two things, if else statements only, but inside the first if we have written one more if else, and inside this else we have written one more if else. Okay, same syntax, having condition, if it is true this must execute, and if it is false, the else block will execute. This is about nested if. And remember, if this outer if condition is false, then this else condition will get executed. Again this else condition, again this false condition, that is else block, have if and else. Again this condition is true, this will execute, or else this, in that way. Okay, this is about the if else story. And let us look what is switch statement. Switch is nothing but, in the name itself, switch to a particular expression. You can write switch to a particular expression, and inside the switch statements you can write different cases. Cases are nothing but you can say like group of conditions. Okay, cases. For case 1, one condition, for case 2 one, and for case 3 another, in that way. And I'm using break statement as well. We'll be learning about the break statement further, but just remember the term. And also we are saying a default. If any of these cases is not executed, then the default block, this is not a block actually, this is a statement, the default statement will get executed or will be printed. Okay, simple. Switch condition as cases and a default statement. Remember, it is mandatory to specify a default. Okay, it is a good programming practice. Now let us look into different types of loops. Loops are nothing but iterative approach. Okay, loop type, we have 4 types of loops: while loop, for loop, do while, and nested loop. It is the 4th type. Nested loop is nothing but, it is like a nested if. In the nested if we have if condition inside if condition, right? In the nested loop we will have suppose if we take while loop, if we say nested while, we can say that while loop inside a while loop. Okay, if we take for, nested for, we can say for loop inside a for loop. If we take do while, nested do while, it is do while inside a do while. Okay, first let us discuss while loop, for loop, and do while, so that we can understand also nested loop easily. So what is while loop? While loop, it repeats a statement or group of statements while a given condition is true. So under a given condition, it repeats a statement or a group of statements. Number of statements depend on the programmer, but the condition, that condition is true, then it will repeat that statement. Simply we can say that it tests the condition before executing the loop body. So the condition is mandatory. If you write a condition, then that statement will be executed again and again. Okay, and remember, the same statement will not be printed. If you have the same statement, it will be printed, but remember, you need to specify some increment. Okay, suppose if I say I plus plus, okay, till 10, till 5, if I say only 5 times, that must repeat. Like for first time, again repeat, must repeat second time, again for third time, fourth time, and fifth time. So specifying a condition inside any of the loops is mandatory. What is for loop? For loop executes a sequence of statements multiple times, okay, and abbreviates the code that manages the loop variable. Okay, what is the difference between while loop and for loop is both are almost similar, but inside the while loop you can specify a condition. You can only specify a condition, but inside a for loop you can initialize, you can specialize a condition, and also you can give any updates in the sense, like I have given increment each time, like for the first time it is 1, right? Increment it, for the next time it must become 2, for the next time it must become 3, in that way. Okay, so inside the for loop, for parenthesis, inside this parenthesis we can write initialization, condition, and updation. Okay, and what is this do while? Do while is different from while loop and for loop. It is similar to while loop, but what happens is the condition is being tested at the end of the loop body. Nothing but after the loop gets ended, the condition will be tested. Okay, that is the significance of do while loop. And nested loop, as I said, loop inside a loop, one or more loop inside any another while, for, or do, etc. Okay, this is about different types of loops, right? This is very important. There are two types of loops: entry control loop, exit control loop. As I said, loops are iterative statements. Iterative statements are nothing but control statements. So loops are of two types: entry control and exit control. In the name itself, entry controlled is nothing but you are controlling by giving some condition. So if that condition is given at the starting of your program, nothing but at the entry level, then that is called as an entry controlled loop. So as I said, for while loop, while inside parenthesis we will give condition, after that the block of statements will get executed, will be getting executed. Okay, and in for loop also we will be giving a condition as well. After that condition, the block, if that condition is true, the block will get executed. So we are giving the condition at the start of the program or at the start of the loop. Whereas exit control, you can take example of do while. As I said that inside do you can add block of statements, but at the end the condition will get executed. You can check here. It tests the condition at the end of the loop body. So do while is exit control, nothing but at the end it checks for the condition. Okay, you can check the basic syntaxes for the for loop: initialization, condition, and updation. And for while, giving a condition. Okay, for while we are giving a condition, and for do, just like executing a block of statements, and after that do gets executed, we are writing while condition. Okay, this is about entry control and exit control loop. And flowcharts are very important in C, you know, right? I have given a flowchart for iterative statements and also for conditional statements. You can check. This is an Eclipse where I am writing start. Okay, start is nothing but start the program or start the reading of instructions. After that, using an arrow, downward arrow, I am giving a rectangle. Inside rectangles, you can give initializations and body or the statements which you write, like printf, scanf, whatever. Okay, in the rectangles you can mention those initializations. So we have discussed, right, in sequence in the starting of the control statements, we have told that the statements in the sequence control are represented in the form of rectangles. Okay, so here also the same things comes under. Initialization is inside a rectangle and body of the loop is also inside a rectangle. And remember, condition, it's a rhombus like structure. Okay, and for this condition, if that condition is false, the end of the it goes into the end of the statement, and if that condition is true, the main body of the loop gets executed. And you can check for this. This is an iterative approach. This is about conditional statements. And iterative approach: start, initialization of loop counter, giving an initialization, and after that the body of the loop, and whatever the updates are there, here also we are giving it in the rectangle, and after that while condition. So you can say this as what? This is a do while loop. In the do while, first we are writing the body of the loop using do condition, and after that we are giving inside the do part, after that we are giving while condition. Okay, after this, if that condition is true, again it must iterate, after that otherwise false. You can check while and do while. Okay, In the while, first only you are specifying the condition, and if that condition is false, then the statement will whatever the statements you write below while, after that while, okay, after that while block will get executed. And if the condition is true, the main body which you have written inside the while loop will execute. And again, what is this line indicates? It is an iterative, okay, again running, repeating the process for an incremental, repeating the process for an increment. And for false, just whatever you have written in below the while, that will be executed. And you can check do while, flowchart for do while. The main body will get executed first. After that, it checks for the condition, that is the test expression. If that is true, again the main body, it will go, the control moves to the main body of the loop. If that is false, whatever the statements you write below the loop will execute. Now let us give some brief introduction about functions. Function is nothing but doing a task, okay. If you want to do a task, you are writing a function. Each object has its own function, okay. Suppose, let us take an example, right? What are the functions of a human? Reading, writing, listening, working, etc. Okay, different object has different function, so we are writing the programs also in the form of functions, okay. So functions are basically of two types: predefined functions and user defined functions. What are predefined functions? In the name itself, predefined, defining the functions in the library, in the C library, the functions which are defined in the C library, okay. Library functions are the best example. And whatever the declarations in the header files you will be giving, right? Header files hash include standard input output .h, that is also predefined, and .dll files. What are user defined? This is the most important thing, okay. If you write up your program in a user defined manner, then it will be a great programming practice. That is the point which brings out your way of thinking about that problem, okay. User defined, user customized functions, okay, user customized functions to reduce the complexity of big programs. So what is the main use of this user defined functions? Simple, to reduce the complexity of big programs. Suppose, let us take an example. You have an algorithm. If you want to find the size of a integer, we are using what function? Size of function. Suppose I want to write a user defined code for it. Instead of using size of, I want to write a code for it, right? Actually for integer character it is not possible, but if we take let us take arrays. In the further concepts it will be coming. If we have array, okay, array has group of characters, let us say, okay, and if I want to know the size of that array, you will be using some predefined function. Suppose I want to do it in a user defined manner, then what can you do? It's very simple. You will be writing some loops, or you will be using some conditions, right? Suppose, let us say, right, you will be using a loop, and till that loop reaches to the end of your string, you will be increasing your length of your what we say, let us give a separate variable for length, okay. Till it reaches to the end of the string, that word will be taking out the length or incrementing the length number for it, okay. So that is a user defined thought process, okay, and it is very important, right? That's it for today, guys.